Hello students, in this video I am going to start new chapters, force and laws of motion, and we will discuss about first of all that is the basic concepts of the force. So we know that force is an external effort in the form of push or pull that produces acceleration in the body on which it acts. So force is an external effort in the form of push or pull that produces acceleration in the body on which it acts. When force is applied in the body, then it can change the state of rest or of uniform motion of the body, or accelerations can be produced in the body. So force can be expressed as the product of mass of the body and the acceleration produced in the body. So force applied on the body is equal to the product of the mass of the body and acceleration produced in it. So force has both magnitude and direction. So it is a vector quantity and it can be expressed as the product of mass and accelerations. Therefore, M is equal to ma, where mass, M is the mass of the body and A is the acceleration of the body. Now, if the same force acts on the body, so one note here, if the same force acts on a body of mass m1 and acceleration is produced a1, and same force acts on the mass m2 and acceleration is produced a2. So therefore we can write here, if force A acts on a body of mass m1 and acceleration produced in it is a1. Similarly, if it acts on mass m2 and acceleration produced in it and acceleration produced in it is a1 is a2, then m1 a1 is equal to m2 a2, or we can write here m1 by m2. We can write here m1 by m2 is equal to a2 by a1. So if the same force applied on a body of two masses m1 and m2, and then the more acceleration will be produced in a body of less mass, and less acceleration is produced in the body of more mass. So acceleration is inversely proportional to the mass of the body, and we can write here m1 by m2 or a2 by m1. Therefore we can write here A is inversely proportional to M. So acceleration is inversely proportional to the mass of the body. Now we will discuss about the units of the force. Units of force. We will discuss about units of force. So first of all, we will discuss about SI unit, then CGS unit, then gravitational unit we will discuss about. it. So SI unit of force. First is SI unit of force. SI unit of force. SI unit of force, that is equal to kg meter per second square. Kg meter per second square. Because it is equal to MA and SI unit of mass is kg and SI unit of acceleration is meter per second square. So in kg meter per second square or it is equal to Newton. So SI unit of force is Newton. Second, CGS unit of force. CGS unit of force. CGS unit of force is gram centimeter per second square. Gram centimeter per second square. Or this is time. And the relation between 1 Newton is equal to 10 to the power 5 time. You can write relation 1 Newton to 10 to the power 5 time. So relation between SI unit and CGS unit, that is equal to 1 Newton is equal to 10 to the power 5 time, or that is gram centimeter per second square or time. Now gravitational unit of force. Third is gravitational unit of force. Kilogram weight. Gravitational unit of force. Gravitational unit of force. That is kilogram weight. Gravitational unit of force is kilogram weight. Kilogram weight. Or simple you can write kg weight. Kg weight. And 1 kg weight is equal to 1 kg weight is the amount of force that produces 9.8 meter per second square acceleration in a body of mass 1 kg. So we can write here, therefore 1 kg weight. The 1 kg weight is equal to 1 kg into 9.8 meter per second square, or this is equal to 9.8 Newton. So 1 kg weight is the amount of the force that produces 9.8 meter per second square acceleration in a body of mass 1 kg. So 1 kg weight or 1 kgf you can also write. 1 kg weight or 1 kgf you can write. 1 kgf, kilogram force. So 1 kilogram force or 1 kg weight, that is equal to 9.8 Newton. Now we will discuss about the effects of the force. Effects of the force. There are many effects of the force. Effects of force. So force can change the shape or size of the body. Force can change the direction of motion of the body. Force can stop a moving body or brings in motion a stationary body. Force can increase or decrease the speed of the body. So there are many effects of the force we can write. So force can change the shape or size of the body. Force can change the direction of motion of the body. Force can change the speed of the body. Force can stop a moving body or can accelerate a stationary body. The first effect is that force can change. Force can change the shape or size of the body. Second, force can change the direction of motion of the body. Force can change the direction of motion of the body. Direction of motion of the body. Third, force can change the speed of the body. Force can change the speed of the body. Force can change the speed of the body, or force can stop a moving body or brings into motion a stationary body. So, fourth effect is force can stop a moving body or brings a stationary body in motion or brings a stationary body in motion. So these are the common effects of the force. Now we will discuss about the different kinds of the force. So first of all, we will discuss about the resultant force. First of all, we will discuss about the resultant force. What is the meaning of resultant force? If a single force acting on a body produces same acceleration as that of the two or more forces acting on it, then the single force is called the resultant of the individual forces. So, if a single force acting on a body produces same acceleration as that of two or more forces acting on it, then the single force is called the resultant of individual forces. On it, then single force is called resultant. Single force is called resultant of individual forces. If two forces acting in opposite directions, then the resultant force will be equal to the difference of the forces if they have different magnitudes. So now examples here. First cases, suppose that two opposite forces acting in a body. Suppose that one force is F1, other force is F2. Here F1 is greater than F2. Then the body will move along the direction of the force F1. Or now resultant force will be equal to the F1 minus F2. So if the two forces acting in opposite directions, then the resultant force will be equal to the difference of the individual forces. Second, if two forces acting in same direction, one is F1 and other is F2, then the resultant force F will be equal to sum of the forces, that is equal to F1 plus F2. If two forces acting normally to a body, then the resultant force will be equal to the under root F1 square plus F2 square. Third case is here. If two forces acting normally, this is a body, and the two forces acting on it in perpendicular directions. Two forces acting on it in perpendicular direction. One is along x-axis, other is along y-axis. Then the resultant will act along the direction of the OA. Or here it will be equal to resultant force is A here. So here A will be equal to under root F1 square plus F2 square. So if two forces acting normally or perpendicularly to each other, then the resultant force will be equal to the under F1 square plus F2 square. Now if two forces acting in at some angle other than 90 degrees, suppose that is a one force is F1 and other force that is F2. And these two forces acting at some angle, suppose that this is a theta. So make a parallelogram here. And the resultant force will be along the direction of the diagonal of the parallelogram here. Suppose that this is A, this is B, this is C. So the resultant force will act in the directions of the diagonals of the parallelogram. Suppose that at some angle this angle is alpha here. So the resultant force A will be here, that is equal to F1 square plus F2 square plus 2 F1 F2 cos theta. Or if theta is 90 degree, then cos 90 is equal to 0. Then here we can write if theta is 90 degree, cos 90 is equal to 0. Therefore, we can write here under root F1 square plus F2 square. So in this way, if the two forces acting other than 90 degree, then we will use general formula F1 square plus F2 square plus 2F1 F2 cos theta. And the direction, in which direction the resultant force will act. So the directions we will find here, that is equal to, this is the, we will find the perpendicular, and again we will draw here for finding the direction, in which direction the force will act. Then we will draw the perpendicular here. We will draw the perpendicular here. That is, suppose that this point is A and this is a theta, this is also equal to theta here. This is F2 also. Here is, that is F1 here. So now we will find this CM here. Here CM is equal to perpendicular by base, or CM here, that is CM is equal to here tan theta is equal to CM by OA, or simple literally. Right here sin theta. Sin theta is equal to CM by CB. Therefore, CM is equal to CB sin theta, we will write here. Or this is equal to CB is F1, so that is F1 sin theta. So that is also equal to F1 sin theta. Or similarly, Bn is equal to, similarly Bn is equal to, we will write here. Similarly, Bn is equal to F1 cos theta. So tan theta is equal to tan theta is equal to Cm by OM. Cm is equal to F1 sin theta and OM is equal to OP plus PM. OP plus PM, that is equal to F1 sin theta divided by F1 plus F1 cos theta. So by using this formula, we can find the direction. Here that is equal to tan alpha. Here we will write that is equal to tan alpha. Tan alpha is equal to Cm by OM, or Cm is equal to F1 sin theta. OM is equal to OP plus PM. OP is F1 or PM is F1 cos theta. So tan alpha is equal to F1 sin theta divided by F1 plus F2 cos theta. So by putting the value of the angle, and we can find the direction, in which direction the resultant force will act. So if the resultant force is along the OC, then we can find the angle with the x-axis. in which direction the resultant force will act. So, simply resultant force is a single force that produces same acceleration in a body as that of the two or more forces acting on it. Now we will discuss about the balanced forces. Balanced forces we will discuss. Discuss about the balanced forces. Balanced forces. Balanced forces. A set of forces acting on a body. A set of forces. Balanced force is a set of forces acting on a body, produces no acceleration in it. It means that net force acting on the body is the zero. So a set of forces acting on a body, a set of forces acting on a body produces no acceleration, in it are called balanced forces. Balanced forces. So in this case, net effective force acting on the system is zero. Suppose that there are three forces acting on the body load. One is F1 in this direction, other is F2 in this direction, and F3 in this direction. If the net effective force in the zero, it means that first of all, we will calculate the resultant of F1 and F2. We will calculate the resultant of F1 and F2. That is equal to F1 plus F2. If F1 and F2 are balanced, then F1 plus F2 will be equal to the minus F3. If F1, F2 and F3 are balanced forces, then F1 plus F2 is equal to minus F3, or F1 plus F2 plus F3 is equal to 0. So if the net effective force acting on the system is 0, then these forces are called balanced forces. So if two equal and opposite forces acting on the system, then these two forces are said to be balanced. So if two equal and opposite forces acting on the system, acting on a body, then the net effective force will be 0. So if two equal and opposite forces acting on the system, then these two forces are called balanced forces, because the net effective force acting on the system will be 0, or the acceleration will also be equal to the 0. So balanced forces, a set of forces acting on a body, produces no acceleration in it. And next is unbalanced forces. Next we will discuss about unbalanced forces. Unbalanced forces. Unbalanced forces means a set of forces acting on a body produces non-zero acceleration in it, or produces some acceleration in the body. So unbalanced forces. Unbalanced forces. Discuss about unbalanced forces. Unbalanced forces means a set of forces. A set of forces acting on a body, produces non-zero acceleration. Produces non-zero acceleration in it. Produces non-zero acceleration. Non-zero acceleration in it are called unbalanced forces. Unbalanced forces. So due to unbalanced forces, the state of the body changes. So unbalanced forces acting on the body changes its state of rest or of uniform motion of the body. So unbalanced forces acting on the body, changes its state of rest or of uniform motion. Body changes its state of rest, or uniform motion. Uniform motion of the body. So, if two equal, suppose that, as for example, here you can say, if F1 and F2 forces acting on the body in opposite direction, this is F1, this is F2. Here F1 is greater than F2, then the body will accelerate in the direction of the F1. Here the net effective force acting on the body, that is F net is equal to F1 minus F2. So the net effective force acting on the body, that is equal to F1 minus F2. So now balance force and balance force. Then we will discuss about the normal force. About the normal force. So normal force is a perpendicular force. Is a perpendicular force. Perpendicular force acting. Force acting on the surfaces of contact. Surfaces of two bodies in contact. So normal force is a perpendicular force acting on the surfaces of two bodies in contact. Suppose that a book is placed on the table. A book is placed on the table. So book apply normal force on the table in the downward direction, and the table also apply force on the book, that is F2, in the upward directions. So what book apply force on the table in the downward direction, that is F1, and table apply force on F2 in upward direction. So here F1 and F2 are normal forces. Here F1 and F2 are normal forces. Now next is tension. Next is tension. We will discuss about the tension. Tension, when a body is tied to a string or a spring, then the string or a spring apply force on the body in upward directions. That upward force applied by the string or a spring on the body tied to it, that is called the tension. So tension is an upward force. Tension is an upward force. Upward force applied by the string or a spring. Tension is an upward force applied by a string or a spring on the body the body tied with it. Tied with it. So suppose that this is a fixed point, this is a spring, and a block is held with a spring. Then the tension will act in the upward direction, that is a tension, and the weight of the body that will act in the downward direction. So tension is an upward force applied by the spring on the block. Similarly, a block is tied with it, then here tension will also act in the upward direction. So an upward force applied by the spring on the block that is tied with the spring or spring, that upward force is called the tension. Now, force by a spring. Force by a spring. Suppose that two blocks are attached with the spring, and the spring are stressed, then the force will act towards each other. So block A and block B, and when a spring is stressed, when a spring is stressed, so when a spring is stressed, then force acts on each block towards each other. And when a spring is compressed, like this, when a spring is compressed, then force act on the spring in the opposite directions. So that is a when a spring is compressed. In this case, when a spring is compressed. So when a spring is compressed, then force applied by the spring then on this block towards each other. And in this case, when a spring is compressed, then the force applied by the spring on the block in opposite directions. Thank you.
ये जो लिखता है